Good morning, geometry students. Happy Thursday. Welcome to today's lesson. The flip grid is right there. This was a suggestion, today's flip grid was a suggestion from one of my students. Roast me. What can you come up with? I'm very curious. I'm very curious to see. You have already found today's YouTube lesson if you are here. Please pause the video and try this problem in your notes and then unpause it to do it with me. Okay. We are asked to solve the right triangle and round decimal answers the nearest tenth. I notice right off the bat that I have two of my sides, so the easiest way to find the third is gonna be a squared plus b squared equals c squared. I know this side has to be c. Doesn't matter which one a and b are, so I have 20 squared plus 21 squared equals c squared. I do not remember what 21 squared is. Oh, I should have been able to remember that. Oh well. Add those together. And take the square of both sides. And you get 29 exactly. 29 exactly. No decimals there. Love it. I love that. Okay. Well, awesome. We know all three of the sides. Cool. To solve the right triangle, we need to know all three of the sides and all three of the angles. So now, pick an angle. Doesn't matter which one. Let's look at D. If we're looking at D, that makes this the opposite. This, of course, is the hypotenuse, and this is the adjacent. I can use whatever I want. If I have, let's see, write it down here. So, I can use whichever one of these I want because I have all of them. I know that C is 29. And I know what the opposite and the adjacent are, so we can use whatever we want. Shall we? I don't know, let's use tangent. We haven't used tangent in a while. Let's pick tangent just to give him some love. Okay, so tangent of angle D is opposite over adjacent. And now you remember what we do. We're going to take tan inverse of both sides. Make sure you're in degrees. And we get that D is approximately 46.4, rounding to the nearest 10, 46.4 degrees. And now, see, new color. Now we want to find angle E. Oh, that's not a new color. We want to find angle E. There are several ways we can do this. We can either pick another trig function and do, you know, hypotenuse, opposite, adjacent. We could do all that. Or, remember what we did yesterday was, I know this angle, and I know this angle now. So let me just add them up. I know that, D plus E plus 90 is 180. So D plus E equals 90. We know D is 46.4 plus E equals 90. So I'm just gonna minus the 46.4 and E is 43.6. So the measure of angle E is 43.6 degrees. Ta-da! All three angles, all three sides. So we have solved this right triangle. Beautiful. Awesome. That was the entry task. Moving on to the learning target and the success criteria for today. The learning target is I know a new way to find the area of a triangle. And I know what the law of sines is. Okay. And the success criteria says I can find the areas of triangles and use the law of sines to solve triangles. So basically, can you use that new way of finding the area of a triangle, and can you use the law of sines? So I think we have 3 examples today, so let's jump right into it. First thing you need to know is the new way to find the area of a triangle. So you should pause this video and write these things down. Here is the way to find the area of a triangle. And this does not need to be a right triangle. I know it looks like that's a right angle, but this actually doesn't have to be a right triangle. It can be any type of triangle. So basically, if you take half of 2 of the sides, so B and C, and then the angle in between them. So it's kind of like the side angle side that we've been looking at in chapter 5. So, and you see over here, let me change colors. We go AC, so A and C with B, the angle in between. And it works the same way. I can, yeah, just for sake of, we have A and we have B, and then we have the angle in between. So, you take 2 sides and the angle in between, and if you take half of those 2 sides and the sine of the angle in between, then there you go. You got the area. So, yes, pause that, write that down, and now let's move on to an example. Alrighty. So, one more thing I should mention up here is notice, let me get my black pen back. Notice that the angle, or the side opposite angle A, is A. You see that? And, ooh, it is too messy over here. So I'll just, I'll do it on this triangle. If I go opposite angle A, this is going to be the side that I call A. So whatever side is opposite the angle, they're going to have the same letter, but angles are capital letters and sides are lowercase letters. Okay. And then, well, let's just use the same color. So the angle opposite B, so this is going to be B. And the side opposite angle C will be C. Wonderful. So now remember the formula that was just on the last page is that the area equals 1/2. I need, let's see, I have side, angle, side, so I'll use these. I'll use 1/2 BC times the sine of A. And now you just gotta plug in what you got. So, 1/2 B is 17. C is 19. And angle A is 135, so we're going to take sine of 135 degrees. And now you just stick that whole thing in your calculator, because I don't know what that is. So 1/2 times 17 times 19 times sine of 135 degrees is 114.2. Units. They didn't give us any units, but remember that this is area, so we're gonna have units squared. Units squared. And there you are. That's all. As long as you remember this guy, you're gonna be just fine. Yes. Handy little trick for finding the area of a triangle, because sometimes you don't have the height of a triangle. Which is where this formula comes from, actually. It comes from you're basically just finding the height, but we won't get into that. Unless you really want to know, then ask me. Then ask me and we can get into it. Alright. We can check our answer and look at that. Square units, we were right. Alright, next thing we're going to do today is the law of sines. And again, this looks like a right triangle, but it's not. This does not have to be. Does not have to be for a right triangle. This can be for any triangle, which is what makes it so special. Normally, SOHCAHTOA can only be used for right triangles, but the law of sines, oh, any triangle you want, any triangle you want. So pause the video, put the red boxes in your notes, and then unpause it because we're going to talk. Notice how there are two different boxes here. There's this one and this one. And you're like, wait a minute, sine of angle A over A equals sine of B. Wait a minute. And then this box is just this one flipped upside down? Like, what? Why am I allowed to just flip them upside down? Well, what this is saying is that these ratios are equal. So this ratio is equal to this ratio, which is equal to this ratio. And, so imagine if this is like 3/4 equals 3/4 equals 3/4. That would be fine. 3/4 equals 3/4. That totally makes sense. If I take all of that and I just flip it over, I'll get 4/3 equals 4/3 equals 4/3. So are they different? Sure, because you're comparing. Yeah, sure, they're different. But this is still a true statement. 4/3 does equal 4/3, which equals 4/3. Like, that is still a true statement. Just like this is a true statement. So if this left box is true, the right box is also going to be true. And vice versa. If the box on the right is true, the box on the left will also be true. So it doesn't matter which one you use. It's because we're just comparing ratios, doesn't matter if you're comparing the angles to the sides or the sides to the angles. All right. Yes. Fantastic. So, I know you just heard me talk, but let's see. Let's see what it looks like in an example. We're going to go through a few different cases. This is the angle side case. We're going to go over another one next. The bad word. Remember how the bad word doesn't work? The SSA case doesn't work. Well, with the law of sines, it can technically work. You might learn about that next year. Hopefully we'll learn about that next year. If you want to delve into it, we can definitely talk during like my live stream or something like that. But right now, I don't want to get in. I'm not going to do that example right now. Okay, so we are going to solve the triangle. Solve the triangle, which means we're going to find all the sides and all the angles. And we're going to round decimal answers to the nearest tenth. Okay. All right, well, the first thing I notice is that I have two of the angles. So this third angle is going to be nice and easy to find. 107 plus 25 is 132. Let me double check my math, because I have been wrong on these videos before, and it's cringeworthy after the fact. Okay, so angle A is 48 degrees. 48 degrees. Awesome, awesome, awesome. And now, remember what our law of sine said, and remember, it doesn't matter if you put the side length on top and the sine on the bottom, it does not matter. I normally pick whichever way makes it easier to solve. If the unknown is on the top, it makes it easier to solve for me personally. Not saying that's the same for you. Okay. So this is our law of sines. Remember, we can flip it upside down and it's the same thing. So now I'm just going to fill in all of these pieces. We don't know what A is, but we know that we have... What on earth just happened? No! Get out of here. Get out of here. Nobody wants that. That was weird. I apologize for the brief interruption. Okay. So we have A over sine of 48. equals B is 15. Remember what's opposite B? The side opposite angle B. Sine of 25. And we don't know what C is, but we do know that angle C is 107. Okay. Alright. Now, I hope that you didn't forget how to use your butterflies. How to do your cross multiplication, because it's coming back. Alright. So, now, notice how I don't know A, and I don't know C. Well, look at that. If I just cross multiply like this, do my butterflies, I can find it relatively painlessly. So I'll get A times sine of 25 equals 15 times sine of 48. And then we just divide both sides by sine of 25. And we get that A is approximately, oh boy, 15 times sine of 48 divided by sine of 25 is 26.4. Nearest tenth. Nearest tenth. And we don't have any units on that. No units, so I'm just gonna leave it like that. Beautiful. Are we done? No, we are not done because we needed to solve the triangle. And remember, solving the triangle means finding all the sides. So we still need to find good old C over here. Let's do this in a different color so that y'all can see okay, because we're gonna butterfly it again. And we're gonna get C times sine of 25 equals 15 times sine of 107. And divide by sine of 25. And we get C is approximately 15 times sine of 107. Make sure you're in degrees. Divided by sine of 25. And C is approximately 33.9. Ta-da! Okay, look at that. 1, 2, 3 sides and 1, 2, 3 angles. So we have solved this triangle. I have a question for you. Once we found 2 of the sides, so we had the 15 up here, once we found A, why didn't we just use the Pythagorean theorem? If I have 2 of the sides, can't I use the Pythagorean? Maybe, I hope that you came to the conclusion that no, of course we can't use the Pythagorean theorem, because this is not a right triangle. That triangle is not a right triangle, and remember, we can only use the Pythagorean theorem if we have a right triangle. Okay. Beautiful. Fantastic. Let's see if we were right. Ah, beautiful. Beautiful. We were. Okay. Last example for today. Using the law of sines with the angle side angle case of a triangle where we have an angle, a side, and an angle. Okay. A surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from the north picnic area to the south picnic area. Find the length of the bridge. Okay, so the bridge built from the north picnic area to the south picnic area. So we're looking for this. This is what we want. We just want C. That made that hard to read. We want C. So we just have to find the length of the bridge. We don't have to solve the whole triangle. Okay, cool. So make sure that you pay attention to what it's asking you, because if you solve the whole triangle when you didn't need to, I mean, hey, good practice, but you don't have to. Okay. Alrighty. Let's see. Well, I know. I'm just gonna write down my law of sines first. That A over sine of A equals B over sine of B, which equals C over sine C. And now I'm just going to fill in the information that I have. So, I know, let me look at my diagram over here. I know, let's see, this is side B. So I know that B is 150 over, but I don't know what angle B is. Or do I? Oh my goodness. We can actually figure out what angle B is, because we just have 71 plus 60 is 131, 180 minus 31. I'm gonna do this just to make sure I don't get it wrong. 49 degrees. Angle B is 49 degrees. Always check and make sure that you, before you say, like, oh, I don't know what that angle is. Could you know what that angle is? Could you use the triangle sum theorem? Okay, so sine of 49 degrees. And let's see, I don't know what C is. C is what I'm trying to find, but I do know that the angle opposite is 60. And this is a very important part of these problems, is you have to pay attention to what angle C goes with side C. Do not put 49 with C. 49 doesn't go with C. 49 goes with B, goes with the 150. And A goes with the 71. But do not, do not mix up which go with which. Alright, and then we have A. We don't know what A is, but we know that the angle that goes with A is 71. Okay. Fantastic. Oh, and you can't. I'm blocking some of that. That's okay. Alright. You know, it doesn't even matter that I'm blocking that part, though, because we are not going to need this. How do I know that? Because what I am trying to find, remember that I'm trying to find C. C is what I wanted. So, when I cross multiply, I don't even have to use the A. I can just use these two. And I can once again cover up this part of the problem over here, because I don't know what A is, so that doesn't help me to cross multiply here, because I don't know what A is. If I knew what A was, then I could have used it to cross multiply if I wanted to. But I could just use B, because I have all of that information there. There is no variable in this part of the problem. It's just numbers and values, and we love that. Okay, so if I cross multiply here, I get C times sine of 49 degrees equals 150 times sine of 60 degrees. Divide by sine of 49. Why am I dividing by sine of 49? It's to get rid of it over here. So I can get the C all by itself. And now C is approximately whatever that is. I don't know what that is, so I'm going to put that in my calculator. 150 times sine of 60 divided by sine of 49. And C is approximately 172 point... It doesn't say what to round to. So I'm going to round to the nearest tenth and say 0.1. And remember, don't forget your units, which are meters. So the length of the bridge is 172.1 meters. Awesome, awesome. Fantastic. Again, I want to highlight just how important it is that, see how that is C, and this is B, and that is A, and A. Make sure that you are aligning side A with sine of angle A. Side B with sine of angle B. It is incredibly important that you stay consistent with that. Otherwise, you're not using the law of sines. You're not following the law. You're breaking the law. And we don't do that. We do not do that. Okay. Let's check and see if we were right. Oh yeah. Awesome. Coolio. Alright, so that is everything I have for you today for geometry. If you have questions, tune into Mrs. Dodger's live stream every weekday from 12 to 2. Today, Mr. Dodge and I are going to be playing Rocket League until you ask me questions. And when you ask me questions, I will answer your questions. I'm not just going to be like, no, Rocket League, like that's no. But we are, we're going to have some fun with that. So you can tune in to watch us and hang out, or you can ask questions. Because questions are fantastic, and I love questions. Alright. Next is the homework for today. The homework, right? Homework for today is, first 4 questions, find the area. Find the area of the triangle, and the last 4 questions are, use the law of sines. Is it the AAS case, or is it the, ASA case? You'll have to find that out for yourself, but they're both relatively painless. Okay. And the launch. Your launch for today is from Zig Ziglar, and it says, what you get by achieving your goals is not as important as what you become by achieving your goals. Think about that for a minute. Just think about it. What you get, the material gain that you get by achieving your goals, is not as important as what you become. So the character development and the growth you go through to get your goals, that's more important than the actual goal that you met. So if my goal is to buy a house, once I have that house, that's not as important as what I went through, the hard work and the research and the looking and the browsing for houses and the talking to, all of the research and hard work that went into getting that house is more important than the actual house itself. In the grand scheme of things, right? Of course the house is important. Not saying the house isn't important, but the character development is going to help me a lot more than having the house. Because I still got to pay a mortgage once I got the house, right? So unless I went through all that hard work, I'm not going to have the hard work, or I'm not going to have the work ethic to make my mortgage payment. So, maybe not the most relatable example, but an example. So, what you get, not as important as what you become by achieving your goal. Okay, that is all I have for you today. Thanks for tuning in, thanks for watching, and hope to see you during the live stream later today. Bye!